Longi's 10-gigawatt manufacturing scale-up, Nell's breakthrough U.S. contract, and Europe's 40% domestic content rule, the 3 September moves reshaping hydrogen economics. Good morning, and welcome to what might be the most pivotal month in the global hydrogen industry's short but explosive history. I'm here to break down 3 seismic developments that are reshaping the electrolyzer supply chain, redefining project scale, and redrawing the geopolitical map of hydrogen technology. September 2025 will be remembered as the month when hydrogen moved from promise to industrial reality. We're witnessing the emergence of a new manufacturing paradigm where Chinese scale meets American innovation and European protectionism, all while the largest off-grid hydrogen project in U.S. history gets the green light. Today, we'll dissect 3 interconnected stories that reveal where this industry is heading. Longi's audacious plan to scale electrolyzer production to unprecedented levels, Nell's breakthrough contract for America's most ambitious off-grid hydrogen venture, and Europe's bold legislative move to secure its technological independence. These aren't isolated events. They're strategic chess moves in a global game worth hundreds of billions of dollars. When Longi Green Energy Technology announced its intention to increase electrolyzer output to 5 to 10 gigawatts next year, the industry collectively held its breath. To put this in perspective, that's equivalent to the entire global electrolyzer capacity installed over the past 5 years, delivered by a single company in just 12 months. Longi isn't just expanding, they're attempting to replicate their solar photovoltaic success story in the hydrogen sector. This is the same company that transformed solar manufacturing, driving down costs from over $4 per watt to under $0.20 per watt through relentless scaling and innovation. Now they're bringing that same manufacturing philosophy to electrolyzers. What makes Longi's announcement so significant isn't just the numbers. It's the manufacturing methodology. Chinese electrolyzer production has already captured 65% of global capacity, and Longi's expansion could push that figure even higher. But this isn't just about market share. It's about fundamentally altering the cost structure of hydrogen production worldwide. The company's approach mirrors China's broader industrial strategy: achieve massive scale to drive down costs, then export globally while building domestic demand. Longi's existing gigafactory approach, which proved devastatingly effective in solar, involves massive automated production facilities that can produce equipment at costs Western competitors simply cannot match. Current industry estimates suggest that Chinese electrolyzer costs are already 30 to 40% lower than European or American alternatives. If Longi achieves their 10-gigawatt target, they could potentially drive electrolyzer costs down by another 50%, making green hydrogen competitive with fossil fuel-derived hydrogen in many markets without subsidies. However, Longi's expansion raises critical questions about technology standards and long-term reliability. While Chinese manufacturers excel at cost reduction and scale, concerns persist about efficiency, maintenance requirements, and component lifespan, factors crucial for industrial customers making 20-year investment decisions. The company has been investing heavily in research and development, partnering with international technology providers and establishing testing facilities in key markets. Their strategy appears to be addressing quality concerns head-on while maintaining cost advantages, a combination that could prove irresistible to project developers worldwide. For SMEs and smaller developers, Longi's expansion could be transformational. Lower equipment costs directly translate to improved project economics, potentially making smaller-scale hydrogen projects viable for the first time. This democratization of hydrogen technology could unlock thousands of projects currently sitting on the drawing board due to prohibitive capital costs. Longi's aggressive expansion comes at a crucial moment. Global electrolyzer demand is projected to increase tenfold by 2030, driven by major hydrogen initiatives in the United States, Europe, and Asia. The company appears to be positioning itself to capture the majority of this growth, potentially creating a China-dominated supply chain similar to what occurred in solar and battery manufacturing. This strategy has geopolitical implications that extend far beyond commercial considerations. As hydrogen becomes increasingly central to energy security and industrial competitiveness, dependence on Chinese technology suppliers raises strategic concerns for Western governments, concerns that are already manifesting in policy responses. Nel ASA's selection as the electrolyzer supplier for the largest off-grid green hydrogen project in U.S. history represents more than just a commercial victory. It's validation of a fundamentally different approach to hydrogen deployment. This 1GW+ project demonstrates that hydrogen can work at massive scale even without traditional grid infrastructure. The project, located in a remote region with abundant renewable resources, will produce hydrogen entirely from dedicated solar and wind facilities. This off-grid approach eliminates grid constraints that have plagued many hydrogen projects and provides price certainty that grid-connected projects cannot match. Nel's technology selection is particularly significant given the competitive landscape. The Norwegian company competed against Chinese, European, and American suppliers, ultimately winning based on their PEM, proton exchange membrane, electrolyzer technology's ability to handle the variable output from renewable sources. PEM electrolyzers are specifically designed for renewable integration, capable of rapid startup and shutdown cycles that match the intermittent nature of solar and wind power. This flexibility is crucial for off-grid applications where energy storage alternatives would be prohibitively expensive at gigawatt scale. The contract represents Nel's largest single order to date and validates their technology platform against major competitors. For a company that has struggled with profitability and market share, this breakthrough contract provides both financial stability and market credibility. This project pioneering what could become the standard model for large-scale hydrogen production. Purpose-built renewable installations feeding dedicated electrolyzer facilities in areas with excellent resource quality but limited grid infrastructure. The economics are compelling. By avoiding grid connection costs, transmission charges, and competing demand for renewable electricity, off-grid projects can achieve significantly lower hydrogen production costs. Industry analysis suggests that well-designed off-grid facilities can produce hydrogen at costs 20 to 30% lower than grid-connected alternatives. The model also provides regulatory advantages. Off-grid projects avoid complex grid interconnection processes and can often secure environmental permits more easily than projects requiring new transmission infrastructure. However, the off-grid approach presents unique challenges. Equipment reliability becomes paramount when maintenance requires traveling to remote locations. Nel's technology will need to demonstrate exceptional uptime and reliability to justify the remote deployment. The scale also pushes electrolyzer technology into uncharted territory. While 1GeW+ installations have been proposed, this project will be among the first to actually achieve commercial operation at this scale. The learning curve will be steep, and early performance will significantly influence industry confidence in large-scale hydrogen deployment. For the broader industry, this project serves as a crucial test case. Success could unlock hundreds of similar projects worldwide, while failure could set back industry confidence in large-scale hydrogen deployment. Nel's contract victory sends a powerful signal about electrolyzer technology preferences in the U.S. market. Despite lower-cost Chinese alternatives, the project developers chose European technology, suggesting that performance, reliability, and perhaps supply chain security considerations outweighed pure cost optimization. This preference could influence other major U.S. projects, particularly those seeking federal funding or support. The Inflation Reduction Act and other federal hydrogen initiatives increasingly emphasize domestic and allied technology suppliers, creating market preferences that favor companies like Nel over Chinese competitors. The European Parliament's adoption of legislation mandating 40% EU-made content in hydrogen technology represents the most significant protectionist measure in the sector's history. This isn't just industrial policy. It's an explicit attempt to prevent Chinese dominance in hydrogen technology, similar to what occurred in solar and battery manufacturing. The legislation requires that hydrogen projects receiving EU funding or support must source at least 40% of their technology components from EU-based manufacturers. This includes electrolyzers, fuel cells, storage systems, and key components like stacks and balance of plant equipment. The timing of this legislation is crucial. European policymakers watched Chinese companies capture 80% of global solar manufacturing and 70% of battery production, often with the help of European technology and investment. They're determined not to repeat this pattern in hydrogen. The 40% threshold was carefully calibrated to be achievable while still encouraging industry development. Current European hydrogen technology suppliers include Siemens Energy, ITM Power, Sunfire, and others who collectively have the capacity to meet this requirement, but only if they scale rapidly. The legislation also includes provisions for technology transfer and joint ventures, recognizing that pure protectionism could slow hydrogen deployment. European companies can partner with international suppliers as long as the partnership involves genuine technology development within Europe. European manufacturers have responded enthusiastically to the legislation, announcing major capacity expansion plans. Siemens Energy has outlined plans to quadruple electrolyzer production capacity, while smaller companies like ITM Power and Sunfire are seeking funding for gigawatt-scale manufacturing facilities. However, the legislation creates immediate challenges for project developers. European-made equipment currently costs 20 to 40% more than Chinese alternatives, potentially making EU projects less competitive globally. The legislation includes transition periods and exemptions for projects already in development, but long-term cost impacts are significant. For SMEs and smaller developers, the legislation creates both opportunities and challenges. Reduced competition from Chinese suppliers could help European technology companies, but higher equipment costs could make smaller projects less viable. The EU's domestic content requirements are already influencing policy in other regions. The United States is considering similar measures as part of hydrogen hub development, while countries like India and Australia are implementing local content requirements for hydrogen projects. This trend toward technological nationalism in hydrogen could fragment the global market, reducing the benefits of scale and specialization that have driven cost reductions in other clean energy technologies. China has responded predictably, criticizing the EU measures as protectionist and threatening retaliation. However, Chinese companies are also adapting, with several announcing plans for European manufacturing facilities to circumvent the restrictions. These three developments are reshaping the global hydrogen supply chain in fundamental ways. Longi's massive scale-up represents the continuation of Chinese manufacturing dominance, while Nell's U.S. contract victory and Europe's domestic content requirements suggest a growing preference for Western technology despite cost premiums. The result is likely to be a bifurcated market. Chinese suppliers dominating cost-sensitive applications and markets without domestic content requirements, while European and other Western suppliers focus on premium applications and protected markets. The scale of investment represented by these developments, tens of billions of dollars in manufacturing capacity and project commitments, is accelerating technology development across the industry. Competition between Chinese cost leadership and Western technology performance is driving rapid innovation in electrolyzer efficiency, reliability, and manufacturing processes. This competition benefits the entire industry by accelerating cost reductions and performance improvements. Even as markets fragment geographically, technology competition remains global and intense. Perhaps most importantly, these developments signal that the hydrogen industry is maturing rapidly. The scale of manufacturing investment, project commitments, and policy interventions suggests that hydrogen has moved beyond the experimental phase into serious industrial deployment. This maturation creates opportunities for SMEs and smaller players who have been waiting for the industry to stabilize. As major suppliers establish clear market positions and technology choices become standardized, smaller companies can make investment decisions with greater confidence. These developments create both opportunities and challenges for hydrogen project developers. Lower equipment costs from Chinese suppliers could improve project economics significantly, but supply chain security and policy preferences may favor Western suppliers despite cost premiums. Developers need to carefully evaluate the trade-offs between cost optimization and supply chain security, particularly for projects seeking government support or operating in strategically sensitive sectors. The success of large-scale projects like Nell's U.S. contract demonstrates that gigawatt-scale hydrogen deployment is moving from concept to reality, potentially creating economies of scale that benefit all project sizes. The competitive landscape is rapidly evolving, with clear implications for different categories of suppliers. Chinese companies like Longi are betting on scale and cost leadership, while European and Western suppliers are focusing on technology performance and supply chain security. Success strategies will vary by market segment and geography. Suppliers need to clearly understand their competitive positioning and target markets that align with their strengths. The scale of investment and policy support demonstrated by these developments suggests that hydrogen has achieved sufficient political and commercial momentum to warrant large-scale financial commitments. However, the emerging market fragmentation and technology competition create selection risks that investors must carefully evaluate. Not all companies will succeed in this rapidly evolving landscape. The interaction between industrial policy, trade considerations, and technology development demonstrated by these cases provides important lessons for policymakers in other regions. Effective hydrogen policy requires balancing multiple objectives: cost reduction, supply chain security, domestic industry development, and international competitiveness. The European approach emphasizes security and domestic development, while Chinese policy focuses on scale and global market capture. Based on these developments, several scenarios are possible for hydrogen market evolution through 2030. If cost considerations dominate decision-making, Chinese suppliers like Longi could capture 70 to 80% of global electrolyzer markets, similar to solar and batteries. Alternatively, trade restrictions and domestic content requirements could create separate regional markets with limited technology and supply chain integration. Competition could also drive rapid technology improvements that reduce cost differentials between suppliers, creating a more balanced competitive landscape. Several factors will determine which scenario emerges: whether Chinese suppliers can match Western technology performance while maintaining cost advantages, how domestic content requirements and trade restrictions develop in major markets, whether early large-scale projects like Nell's U.S. contract demonstrate commercial viability, and how effectively different suppliers can manage global supply chains and technology transfer. For industry stakeholders, these developments suggest several investment and development priorities. Manufacturing scale will be crucial for cost competitiveness. Suppliers need clear technology advantages to justify cost premiums. Understanding regional preferences and policy requirements, and building resilient and flexible supply chains. September 2025 may well be remembered as the month when the global hydrogen industry crystallized its future structure. Longi's manufacturing moonshot, Nell's American breakthrough, and Europe's technological fortress represent three different visions of how the hydrogen economy should develop. The Chinese approach emphasizes scale, cost reduction, and global market capture, the same strategy that proved devastatingly effective in solar and batteries. The European approach prioritizes technology sovereignty and supply chain security, accepting higher costs to maintain domestic capabilities. The American market, as demonstrated by Nell's contract, appears to value technology performance and supply chain security over pure cost optimization. These competing approaches will shape hydrogen development for the next decade. The industry's challenge is ensuring that competition drives innovation and cost reduction while maintaining the diversity and resilience needed for a global energy transition. For SMEs, developers, and investors, the message is clear. The hydrogen industry is moving rapidly from experimental to commercial deployment. The companies and technologies that succeed in this environment will be those that best navigate the complex intersection of cost, performance, policy, and supply chain considerations. The race is on, and the stakes couldn't be higher. The decisions made in the next few years will determine whether hydrogen fulfills its promise as a cornerstone of the clean energy transition, and which countries and companies will control this crucial technology. The hydrogen economy is no longer a distant vision. It's happening now at unprecedented scale and speed. The question isn't whether hydrogen will transform the global energy system, but who will control the transformation.